Lesson 92 is called Estimating Roots. We've worked with square roots plenty, but we haven't had any quite like these. We are used to square root of, let's say, 9, which comes out to a whole number, 3. We're even used to square root of 4 over 9 because we can take the square root of 4 and then we can take the square root of 9 and say answer 2 over 3. We've done this. Whole numbers and fractions. But what we haven't encountered is a number as difficult as square root of 10, which we can't really simplify into a fraction the way we just did, or simplify into a whole number. What do we put for a root? And what the book's going to do is it's going to ask something like, between which two integers is that expression, which makes it a little easier. We don't have to solve. We just have to say generally, estimate about how big will it be. And the beauty of this lesson is when we answer a question like this, we can use guess and check. There isn't some fancy method they insist we use. Our favorite method of all is always guess and check, and we get to use that. So as we guess and check, we know the root is going to be greater than 3. Why? Because 3 is the square root of 9, right? And square root of 9 is under square root of 10. 9 is smaller than 10. We know it's going to be less than 4 because what's 4's square? The perfect square is 16. So we know it's somewhere between these two. So we know the root is somewhere between here. So when it asks between which two integers, we're going to show this like an inequality. We're going to say 3 is less than square root of 10 and square root of 10 is less than 4. If we're reading left to right, it sounds like that. Remember, when we write square root of 10, we're really saying what number times itself will equal 10. And so some number between 3 and 4, not quite 3.1 because that's going to be 9.61, still too low. And 3.2, again, no good because 10.24 is too high. So those numbers by times themselves are not quite it. So you could go on and on trying to find the exact number, but the book, thankfully, will just let us say between which two numbers. So it's good to remember what, again, is the expression square root asking for. We're asking for a number times itself. That'll come in handy later. Let's just hold on to that. For now, let's try this one. Between which two integers is the square root of 69? Make sure you're saying that expression correctly, too. The square root of 69, right? Because there's no number here, so we're going to assume it's a 2. You can almost write this in if it helps you to remember this is a square root. 2 numbers multiplied that are the same to equal that amount. Guess and check. What perfect square can we think is just beneath 69? What number times itself will be less than 69 but close? Perhaps you're thinking about this perfect square. This is why it's so important. We've memorized these and gotten so comfortable with them. What is that? 8. What perfect square is just above 69? Well, let's think. What number's after 8? What's the square for 9? 81. It's going to be somewhere between these. How do I write it? 8 is less than, greater than, less than, square root of 69, which is in turn less than 9. So I know this expression comes out to somewhere between the integer 9 and the integer 8. Reason it was good to review, what do we mean when we say square and square root and radicals and all that is when we get to, what do we call these with the 3, not square root? Call it cubed root. I hope you were thinking that in your head. So between which two integers is the cubed root of 250. We're seeking a number. Let's use the letter R. Times itself how many times? This time, cubed root, cubed 3 times will equal 250. Okay? Let's try a number. Let's just throw out 4 times itself 3 times. What's that going to be? Check it on your calculator. What do you get? Way too low, right? But we're guessing and checking, and the book says to do it that way, so don't feel bad. What about one more above? You don't have to go up too much. You don't have to jump up to 11 or something here, because when you're timesing by itself, numbers jump quickly. What's that answer? Is that right? That's what the book says. What about 666? Let's not do that one. It's the devil's number, and it will be too low, says the book. But 777, God's number, perfect number, is actually too high. That's going to come out to 343. So if I knew 5 was too low and I know 7's too high, that means 6 must have been the low number beneath, and it's between 6 and 7. So we can say, let's change the color, 6 is less than cubed root of 250, which is in turn less than 7. It's between the integers 6 and 7. That is how you will show your answer. Don't just write 6, 7. If you look at the examples in the book, it's not the way it's showing it. That's how we want to show it. Last problem. Between which two integers is, how do I say that? Little 4, 123 under a radical. Correct me if I'm wrong, the 4th root, does that sound right? 4th root of 123. Well, if it's the 4th root and the number under the radical has gotten smaller than last time, we know we're dealing with smaller numbers than last time because we're doing r times itself 4 times. What number times itself 4 times will be just below 123? Well, 2 times 2 times 2 is 8, times 2 is just 16. Way too low. But then you jump up just a little bit, and we're already getting much closer. 3 times itself 4 times. 3 to the 4th is 81. Too low. But if you try the next integer, don't go to a fraction or mixed number. Just go to an integer. What is 4 to the 4th? 256. Look how fast those numbers jump up. So it's between these two numbers. How do I show it? Keep your inequality signs facing the same way. Write this just as you saw it in the problem. These aren't so hard, are they? I think you're going to be okay. Show me practice problems A and B. Raise your hand. Show me those. When those are all set, we got problem set 92 for Tuesday. Thank you.